Hi everyone, my name is Sergey Madaminov. I'm a PhD candidate at Stony Brook University, and today I'm going to talk about our effort to replace the current build system in OVS with a new one called Meson. And this is a joint work with William from VMware. So as we know, OVS works on multiple different operating systems, such as Linux, FreeBSD, Windows, and more. And even though the build process is quite straightforward, there are still some issues specifically on Windows. The reason for that is that the current build system, which is Autotools, is not natively supported for on Windows, or rather it has no native support for Windows. So whenever you want to build, and this is the way it's currently done, OVS on Windows, you'll need to use something like MCS2 for shell emulation and Mingava toolchain. And the second issue is that the Autotools will generate the Makefiles, and the top level one, with the top level one being about 7,300 lines long, when all the generated Makefiles comprise about 8,200 lines of code. So in this talk, I'm going to first give our reasoning why we decided that there is a need for a new build system, and then how we went about choosing a new one, and specifically why we chose Meson as a build system. And then I'll move to the current progress, what is currently done, and what is left to do, and then I'll finally conclude. So why do we need a new build system? And this all started with our attempts to port OVS DPDK to Windows. And the reason we want to do that is because today, when you use OVS kernel on Windows and Linux, due to the differences in their kernels, you ultimately have to maintain like two separate like code bases. And whenever you add a new feature, you will need to do it differently for both of them, as the kernels differ. Which means that you need either a group of people, or ultimately your team should possess a knowledge of both Linux and Windows kernels. And our hope was that DPDK can address this problem by pushing things to the user space, so we can reuse much of the code. But why do we even care about Windows in the first place? And that is actually quite simple. So Windows is widely used operating system in the enterprise world. And overall, so it is an attractive platform, and nowadays we can see more efforts towards bringing some of the current solutions to Windows. And so throughout our attempts, we found that Autotools were causing some issues with our efforts, and I'll explain them slightly before. So to circle back to the original question, there are mainly two reasons why we think that there is a need for a new build system. And the first one is to bring a better experience within the Nix family, and the second one is to have a better experience outside of the Nix family, or specifically Windows. So what are those issues with Autotools? The first one is it has relatively steep learning curve, which makes it somewhat harder to contribute, because whenever there are newcomers, let's say, or somebody wants to contribute something, and it involves understanding the build process, it's not so easy to do. And secondly, the generated Makefiles are just enormous and incomprehensible. And this is a common problem with Makefiles. So it makes it hard to debug and identify issues. But even despite of that, it still works. And so why is it specifically causing issues on Windows? And the reason is the following. So the first is it introduces some level of indirection, which potentially brings more sources of errors or problems, and at the same time, it's also an additional dependency. So if you want to install OVS on Windows, you basically need to bring the shell emulation and that Makefile toolchain, which is an additional step, so it's not so great for adoption. And the way it currently structured, we have a CCL wrapper, so it's a bit of separate code to maintain. And our biggest pain was actually even a different one. It was causing a very slow build process on Windows. And I'll talk about that a bit more. But first, this is the description of the system I used to test the build. So it's a relatively decent laptop with 4 physical cores and a little hyper-threading, has 16 GB RAM, Windows 11, so latest operating system. And for testing the Linux part of the build, I was using the Windows Linux subsystem, the second version with Red Hat Enterprise Linux version 8 as its OS. And for the compiler, we didn't use GCC, but we used Clang. It's supported by OVS, and also Clang is something that's available on Windows. And OVS was one of basically the latest commit as of yesterday. So let's now take a look at some numbers. So the way you build OVS currently is if you clone it from the GitHub, you'll start with the boot, then you perform the configure stage, providing probably flags and specify the compiler, and then you finally run make. And here you can see that it took on my system about 1 minute and 42 seconds to go through all the steps, which is not bad. It's ultimately just a number. But then if you'll try to build the same code, but in same system, but with Meson, using Ninja as a backend. Now we have 2 steps. The first one is basically something like configure. You run the Meson build from the configuration step, and then you do the build itself. And here you can notice I don't need to specify the number of parallel processes. Ninja does it for you by default, which is a great thing. As if you do make, if for some reason you'll forget, you'll just say price and time, and here that's done automatically. But yet you can see that there is about 1.57x speed up using Meson. But then this slide basically presents, or the biggest problem we faced is that when we used Autotools and MCs and Makefile to build OVS on Windows, that process became much longer. We're not exactly yet clear why is this really happening, but so far we saw that to build OVS it took almost 3 hours, which is quite unacceptable. So that causes us to think, what can we do about it? But first, let's also, if you'll try to run again OVS build in MCs with Meson, then we will see that it actually goes much faster. And finally, as Meson, Ninja, and Clang are natively available on Windows, we can run it as is in the developer command prompt that comes with the Visual Studio. And you can see that it basically becomes even faster. So in short, there is no really a good reason to keep using MCs when you can go native, go for a native build and eliminate it just as is. So now with that, let's talk a bit about how did we choose operating system, build system, and why specifically Meson, and then we will move to the current progress and etc. So basically, once you decided that you want or need a new build system, one of the first steps to do is to put down a list of features that you want the build system to have or support. And in our case, the first one was that we want to have a native support for both Windows and Linux, and that also the build system should be efficient and easy to use, as in it should be easy to write the build files and also easy to read them. And as the whole project was driven originally by the obvious DPDK, we also want to have nice interactions with external projects and libraries. But before that, as we are clearly not the first who face those issues, to avoid, in a sense, repeating mistakes, we've tried to look what others have done, and we saw that, for example, DPDK transitioned to the Meson Build System for deprecating Make, so that also kind of took our attention to the build system. So here we can see a table with various build systems and the features I've just mentioned. And for Make, as I've said, it's really not easy to use. It's also not very efficient. And the same goes for Autotools. It's not quite fast, and more importantly, it has no native support for Windows. CMake, on the other hand, checks out all the marks, and also it has a nice integration with Windows, with Visual Studio. It's relatively easy to write CMake files, and works well with external projects, and works also well on both Linux and Windows. So that was one of the candidates. The VS solution, for example, also checks most of the marks, Visual Studio solution, but they're not available on Linux, so we dropped them. And as cons, also relatively nice. However, it's also not particularly fast. Another build system is Bazel, which is quite popular nowadays, and many projects are moving towards using Bazel as their operating system. However, we found multiple reports or concerns that it's not works that well on Windows, and also there are some issues with adding external projects to its build. Specifically, there were threats about issues with adding DPDK to Bazel builds. And with Windows, for example, their documentation mentions installing MSys in WinGW, so we decided not to take a risk on that and go with Meson that was having none of those issues. But one step before, we can see that we had a tie between CMake and Meson, because both of them looked like viable candidates. And to break this tie, we just decided to go with the same system as DPDK to make things easier, as those are tightly coupled projects and something that we originally targeted. So a few words about Meson Build System itself. Its ultimately only prerequisite is to have a Python version 3.6 or higher. And as a VS already uses Python, that was a little concern to us in a sense. Additionally, Meson can be considered as a declarative build system. So instead of writing down exact commands, you more of express what you want it to do, and then it will try to do it for you. And at the same time, the build files are quite easy to read, write, and also understand. They're written in a Python-like language. It's not exactly Python, but it somewhat reminds it, and it takes almost no time to learn it and start writing, and pretty much anyone can just open the Meson build file and read it and pretty much understand what's going on. It also has very simple dependency handling, which is quite helpful, and as we saw, it's also fast. On the other hand, it's also gaining some traction among such large projects as DPDK, Timo, and others, which was also a plus to see that that others also made a choice to use it in their build system. So as I mentioned, you write down all your intentions in files called Meson.build, and they will have a like nice hierarchy, which is quite familiar to most of us. You start with the top level Meson.build file, and in your subfolders, like in OVS, for example, we have Leap and like tools. In others, you will place their own Meson.build files, which will consecutively call from the top level one. And at the same time, and then to use it, you will use pretty much the same commands. You start with Meson build, and then to do the configuration step, and then you do the ninja-c build to execute an actual build. The commands are not exactly the same. There is a slight difference. If you ever built OVS on Windows, you may recall that during the configure stage, you provide additional libraries. So there is a slight difference between building OVS on Windows and Linux. In case of Meson, these libraries, we already put them in the Meson.build file, so you don't need to provide them specifically. However, as OVS relies on POSIX threads, and that is something you place in a relatively random location, during the Meson build stage, you need to provide an additional argument to specify the location of POSIX threads, libraries, and header files. But that ultimately will be the only difference. The rest will work the same. And sorry, I forgot to mention, with regard to the libraries for Windows, for example, in the Meson build file, you, or rather we in the run can specify your target operating system, and if it's Windows, then additional files will be added to the list of libraries, let's say, or something will be performed slightly different. So user don't really need to care about doing that explicitly. That will be already handled in the build files. So what is currently done is that we can build OVS on both Linux and Windows using Clang compiler, and Meson build system with Ninja as a backend, and it's pretty much available already. Also, the way, because of the way some of the files were generated or slightly modified, we had to do something about it. As of now, they use bash scripts, which in turn rely on things like AWK, and those tools like AWK, and those are not really available in Windows. So I just rewrote them in Python and to make them basically cross-platform. So that is basically done. However, there are still many things left, and some of them are checks, as for example, in the configure stage, when you perform checks for if, for example, AFXZP available, or some header-specific headers, that not all of them are implemented, and not all the features are yet added, such as AVX512. It's not particularly hard, it's more of a, that wasn't really on the critical path. The next problem is not really related to the build system, it's coming more from the using a different compiler. Now we have hundreds of compilation warnings, which really should be fixed, and that is not necessarily only touches the Windows code, part of it related to both, to the code shared between Linux and Windows. And the other big part which is left, is to port tests. As currently OVS relies on Autotest framework, which is again Linux specific. But as we want to avoid having MCS and MinGW and all those things in the first place, we need something that will again naturally works. We've checked multiple different testing frameworks, and currently the one from Red Hat called Avocado looks like a good candidate. But we still yet to do that, and that is something not to take lightly, because there are many different tests. So we want to make a really good decision first before starting porting the several thousands of tests. And to conclude, we found that Autotools is something that slows down the progress or expansion of VS to Windows. So to eliminate this problem, we use the different build system Meson to find the root cause, and we found that it worked quite well. Furthermore, it also was faster, which is great and a nice benefit. And we published an RFC in the mailing list proposing to replace the Autotools with a new build system. So feel free to check on that. And of course, we welcome the contribution. So if you get interested, please check it out. Try it, submit patches, open issues, and so on. And of course, feel free to reach if you have any questions. Thanks.
Hello. Let's invite William and Sergey to join us to discuss and answer questions. We have a couple of minutes for that. Thanks, William, and thanks, Sergey. So we don't have any official questions, but there's some discussion in the chat that might be relevant. So Thomas Manjalone comments that Meson isn't mature yet. There's some bugs and features that are evolving, and the latest versions aren't packaged in all distributions, so that you should install from pip. Would either of you like to make any comments on that?
Can you hear me?
Yes, yes, we can hear you.
Okay, great. Yeah, so regarding the installation, that's true, and you basically will install it from the pip. Though that's how you go about most of the Python packages, actually. And, but yeah, that's definitely something to keep in mind if you'll try to install it, to not use the versions coming from the official repositories. Regarding the maturity, I would say it's true. Though many times you won't really hit issues, as most of the time it will be fine. But it keeps changing, and it's not yet in a stable version. I would say, though, we hit several times, as William mentioned. We hit a few times some issues, which were due to the some bug introduced in a particular version or being fixed. But okay. Other than that, I don't really recall any large one, and I hope that relatively soon it's keep maintained quite well and evolved. So I think relatively soon it will reach the more or less stable state.
That's good to know. I want to thank you, Sergey and William, for working on the build system. Build system work is often not appreciated nearly as much as it should be. It's work, but there's not a lot of glory in it. It's one of those things where if it works, no one notices, but if it breaks, then people complain. We do have a sort of a comment, sort of a question from Harry Van Haren in the Q&A panel. He says, good talk. As mentioned on the RFC thread 2, I'm happy to work on the AVX 512 static library part of the Meson build system if required. But he also says that most of it was already done in the POC. Would either of you like to add a final comment before we transition into our break here?
Yeah, I think that part of it was done, but it wasn't really complete. Yeah, so it will be actually great if Harry will take it. I guess we can also take it offline and connect through the email to do that.
Great, and thanks again to Sergey and William.